Many tend to evaluate tanks solely by their gun caliber and armor thickness. But our protagonist today completely shatters this stereotype. Possessing neither the most powerful gun nor outstanding armor, it nevertheless became one of the most formidable and effective machines of its time. Friends, meet the legendary Panzer III, the steel backbone of the Panzerwaffe. Why did a machine with frankly weak armament, which paled in comparison to its Soviet counterparts, actually predetermine the design of global tank building? Why did German generals pray to this tank, while designers of other countries secretly copied its key solutions? Too many non-obvious tactical decisions are hidden in the history of the creation and application of the III. Watch the video to the end. You will learn how a tank written off the books received a triumphant second life as the Reich's most numerous assault gun, and why this exact machine, and not the heavy Tigers, taught the Wehrmacht how to fight. Let's begin. There are machines that everyone remembers, and there are those that remain in the shadows. When it comes to German armored vehicles of the mid-last century, heavy silhouettes with loud names immediately spring to mind. Tiger, Panther. They are drawn on posters, debated on forums, and recognized even by those who have never been interested in military hardware. But the machine we are talking about today almost always stands slightly to the side, modest, without flashy angles, without a legendary name. And this is, perhaps, the main injustice in this entire story. Because it was the Panzer III, or simply the III, that turned out to be the very blueprint upon which almost everything else was built later on. But let's take it in order. By the mid-1930s, German designers were harboring an idea that sounded unusual at the time. A tank, in their mind, should not crawl slowly alongside the infantry, shielding them with its armor. A tank must go first, fast, deep, breaking through defenses and moving forward before the enemy even has time to realize what has happened. Such a task required a special machine. Not the heaviest, not the most protected, but agile, fast, and most importantly of all, clear-sighted. And this is where the designers made a truly subtle move. They divided two different tasks between two different machines. The first model, the one that would receive the Index Panzer IV, was intended to support the advancing forces. A short barrel, a heavy shell, a steady pace, working against fortifications and entrenched infantry. But the second, R3, was conceived for something completely different. Its main objective was enemy armor, other tanks. It had to spot them first, aim first, and remain mobile while doing so. The result was a machine weighing about 23 tons. By the standards of the late 1930s, it was a medium, balanced tank. Not cumbersome, but not fragile either. The crew consisted of 5 people. And remember this number. It will return to our story because one of the main tricks of the entire design was hidden within it. The silhouette was made low, compact, and clean. The logic was simple. The lower the vehicle, the harder it is to hit, and the easier it is to hide in the folds of the terrain. The Germans understood this perfectly and monitored compactness meticulously. But the special pride of the III was its visibility. The commander sat in a small cupola at the very top, from where he could see almost the entire field around him. In the technology of those years, this was rare. Many enemy vehicles were essentially half-blind metal boxes, where the people inside peered at the world through narrow vision slits. But the III looked around with wide-open eyes. And all of this together, weight, silhouette, visibility, 5 men inside, boiled down to one simple thought. It is not the strongest who wins, it is the fastest who wins. Whoever spotted first, aimed first, and fired first won the short tank duel. It sounds almost obvious, but to understand how this elegant idea was born, we have to go back to the very beginning, to the year 1934, to a document with an inconspicuous, boring title behind which lay a very specific goal. In 1934, there was an unwritten rule in Germany: do not call things by their real names. Rearmament programs were in full swing, but no one was in a hurry to make public statements about it. Therefore, every new project was given an innocuous, boring, nondescript name, a technical code name that, if necessary, could be explained in the most peaceful way. The future Panzer III was named Zugführerwagen. Literally translated, this means platoon commander's vehicle. It sounds almost clerical. No threat, no challenge. just service transport for a mid-level officer. In reality, behind this name lay a very concrete task: to create a fully fledged combat vehicle capable of destroying enemy armor. Not escorting, not supporting, specifically destroying. The customer was the Motorization Inspectorate, the structure that in those years was responsible for the entire Army mechanization program. Technical requirements were formulated clearly: a 37mm anti-tank gun with a good rate of fire, protection sufficient for operations on the front line. And this is where the most interesting part begins: a standard radio transmitter in every vehicle, not just in the commanders, in every single one. This requirement seemed redundant at the time. Radio equipment in the mid-1930s was bulky, temperamental, and expensive. In most of the world's armies, radio stations were installed only on the vehicles of commanders, platoon, company. Ordinary tanks communicated with flags, light signals, or sometimes just watched where the commander's vehicle turned and followed it. The Germans decided otherwise. Every Zugführerwagen had to hear and speak independently. This meant that the platoon commander could give orders to all his vehicles simultaneously, directly on the move, without stopping, without throwing flags, and without hoping that his neighbor would spot him. The tempo was not interrupted. The maneuver did not wait. Later, it was this requirement that would turn the III into something more than just a collection of iron, but that was still far off. For now, in 1934, the most hectic stage began: the race of the prototypes. 4 of the country's largest industrial enterprises were brought into the work: Daimler-Benz, MAN, Krupp, and Rheinmetall, each with its own vision of what the chassis, suspension, and layout should be. The task was the same for all, but the solutions were completely different. The series of experimental models received designations from ZW1 to ZW6. These were not finished vehicles, but rather rolling laboratories. On them, they tested ideas that looked convincing on paper, but often presented unpleasant surprises on the proving ground. The discussion around the suspension was particularly sharp. How do you make a 23-ton machine move smoothly, keep its course on rough terrain, and not fall apart from shaking after hundreds of kilometers on dirt roads? There was no answer that satisfied everyone. Each enterprise offered its own. And while the engineers argued, the testers drove the prototypes around the proving ground, counting breakdowns, measuring time, and writing down numbers. Only one was to win. The winner was already preparing for the final test, and its main advantage was hidden not in the armor or the gun, but literally under the hull of the vehicle. When an engineer draws a suspension on paper, everything looks reasonable. The load arrows go in the right directions, the mathematics add up, the parts fit into place. But then the machine goes out onto the proving ground and the paper ends. The mud, rocks, climbs, and descents begin. And what looked flawless in the design bureau suddenly begins to creak, bend, and break in the most unexpected places. This is exactly what all 4 enterprises working on the Zugführerwagen went through in the mid-1930s. The suspension became the main subject of dispute. Not the armor, not the gun, not the engine. It was the suspension that determined everything else. How smoothly the vehicle moved, how accurate a shot on the move was, how quickly the chassis and the crew wore out on long marches. The first prototypes received leaf springs. This was a clear, proven solution that had already demonstrated its reliability on trucks and railway cars. The principle was simple. Several layers of elastic steel assembled in a pack absorbed the shocks of road bumps. Cheap, repairable, technologically understandable. But leaf springs had one fundamental flaw. At high speeds on rough terrain, they did not have time to dampen the shocks. The vehicle bounced and shook. The crew held on with their hands to anything they could hold on to. Accurate firing on the move was out of the question. And this was the main requirement for the III. The next option was spring suspensions of various designs. The idea was the same, an elastic element between the wheel and the hull, but the coil spring works differently, reacting more softly to short, sharp shocks. The results were better, but still insufficient. Under intense movement, the springs began to behave unpredictably, the vehicle rocked, and the accuracy of the shot suffered again. The real turning point occurred when Daimler-Benz became heavily involved in the work with its version of a torsion bar suspension. A torsion bar is a steel rod that works in twist. One end is rigidly fixed to the hull of the vehicle. The other is connected to a swing arm to which the road wheel is attached. When the wheel runs over a bump, the arm rotates, the rod twists, and takes the impact. Then it elastically returns to its original position. It sounds like simple mechanics, and it really is simple mechanics, but in this simplicity lay all its power. The torsion bars were located across the hull, inside it. This meant they did not take up space outside, did not protrude anywhere, and did not catch on the ground or obstacles. The vehicle turned out more compact, the center of gravity remained low, and most importantly, 8 road wheels on each side, each on its own torsion bar, worked independently of one another. In practice, it looked like this. One road wheel hits a ditch, it goes up, takes the shock, and returns. The adjacent road wheels barely feel its movement. The hull of the vehicle glides over obstacles almost level. The commander in the turret does not grab the handrails. The gunner keeps the target in his sights. When the Daimler-Benz prototype entered comparative trials in 1936, the difference was obvious. The vehicle moved more smoothly, was more stable, and what was particularly important, the accuracy of firing on the move turned out to be significantly higher than that of its competitors. In addition, the torsion bar suspension turned out to be unexpectedly durable. An individual rod, when damaged, could be replaced without dismantling half of the chassis. For a machine that was destined to work far from permanent workshops, this had very practical significance. Based on the results of the trials, the choice was made in favor of the Daimler-Benz torsion bar design. This decision settled the longest technical dispute in the history of the three. The suspension was defined. Now it was possible to think further about the armor, the gun, and how to arrange 5 people inside so that they would not interfere with each other but work harmoniously. Because these 5 and how they were placed in their seats would become the next truly important topic. Between the idea and the finished machine, there always stands the same obstacle: testing. Not the kind conducted on a clean, proving ground in good weather with a trained crew, but real ones, longevity, meticulous, with deliberate breakdowns, with extreme loads, with the question, what if everything goes wrong? This is exactly what the 3 went through before becoming a machine that could be relied upon. The series designated by letters from A to D were essentially moving drafts. Ausführung A, this German word means version or model, the first series, released in 1937, numbered only 10 vehicles. They were not sent to active combat units for real use. They were dismantled, studied, overloaded beyond the limit, and observed to see what broke first. The answer was not long in coming. The transmission was the first to give up. The transmission is the entire system of transferring power from the engine to the tracks, the gearbox, final drives, steering mechanisms. In a tank, it operates in conditions that would seem like abuse to any automotive engineer. Sharp accelerations, braking, constant turning, loads when overcoming climbs and ditches. On light vehicles, this is still tolerable. On a 23-ton one, it is a completely different story. Series A, B, and C successively changed transmission parts, searched for weak spots, and reinforced them. Each subsequent variant was slightly more reliable than the previous one. This was not flashy work, no fundamental discoveries, no revolutionary solutions, just patient, methodical elimination of one problem after another. Series D added a new suspension with 8 road wheels to this, the very same Daimler-Benz torsion bar design chosen from the comparative trials. The vehicle immediately began to run differently, smoother, more predictably, more confidently on rough terrain. But the real turning point occurred with the release of Series E and F in 1939 and 1940. Here, the designers finally stopped patching the draft and released a clean copy. The main change was the gearbox. On Series E, they installed a 10-speed semi-automatic gearbox. 10 speeds is a lot. For comparison, most trucks of that time got by with 4 or 5. Why did a tank need so many? The logic was simple. More gears meant more precise selection of the driving mode. The driver could choose exactly the gear needed at a specific moment. Slow and with maximum effort on a steep climb, fast and economical on a flat highway, something in between when maneuvering in confined spaces. The vehicle stopped being a crude tool with 2 modes, slow and fast. It became manageable. The word semi-automatic meant that the driver did not have to manually depress the clutch at every gear shift. A special mechanism did this itself as soon as the lever was moved. In battle conditions, when the driver is simultaneously monitoring the terrain, listening to commands, and dodging obstacles, this was not a convenience but a necessity. In parallel, the armor was reinforced. On Series E, the frontal protection of the hull was 30 millimeters. This did not make the III invulnerable, but it gave it a sufficient margin of safety against most anti-tank weapons it was to encounter. By 1940, when Series F stood on the assembly line, the machine finally corresponded to what had been expected of it from the very beginning: a reliable chassis, a manageable transmission, adequate protection, a 37mm gun with a high rate of fire, a standard radio in every vehicle, and 5 men inside arranged in their places. This last one, the arrangement of people in the turret, was a quiet revolution that few spoke about aloud at the time, but it distinguished the III from most of its contemporaries more than any technical characteristic. Because a 3-man turret is not just a layout solution, it is a different philosophy of combat. Try to drive a car, read a map, and talk on the phone simultaneously. Not sequentially, exactly simultaneously. Most people can manage for about 30 seconds. Then something will go wrong. Either the car will drift the wrong way, or the map will turn out to be upside down, or the sentence on the phone will lose its meaning. Human attention is not made of rubber. It cannot be divided infinitely. Now transfer this situation to a tank turret. Add the noise of the engine, the roar of gunshots, the shaking on the move, radio conversations in the headphones, and an enemy that is moving and not standing still. And ask yourself, how many tasks can one person perform simultaneously without losing quality in any of them? It was this question that German designers solved earlier than others. In most tanks of the late 1930s, the turret was designed for 1 or 2 people. The commander himself searched for targets, aimed the gun, gave orders over the radio, and monitored the situation around him. Sometimes he also loaded. This was not due to anyone's ill will or sloppy design. It was simply believed that this was enough, that an experienced officer would cope. The French Sommois S-35 medium tank was a very decent machine by the standards of its time. Good armor, decent gun, good mobility. It was respected and considered one of the strongest in its class. But only one person sat in the turret, the commander. And he combined everything in himself: searched for the enemy, aimed, pulled the trigger, reloaded, and at the same time tried to monitor the battlefield and control the vehicle through the intercom. In a calm environment, this worked. In a fast, mobile battle, almost not at all. Early versions of the Soviet T-34 tank carried a similar problem. The turret was 2-man, commander and loader. It would seem to be better already, but the commander at the same time performed the duties of the gunner. He himself held the sight on the target and pressed the trigger. He physically did not have time to look for new targets, assess the situation, and simultaneously conduct accurate fire. Soviet tankers knew perfectly well about this drawback. It cost them very dearly in the first years. 3 men sat in the turret of the III. The commander was at the top, in a small cupola with all-round visibility. His only task was to look, to search for the enemy, assess threats, make decisions, give commands. He did not touch the gun. He did not load. He only thought and observed. The gunner worked with the sight and the gun. Having received a command, he rotated the turret, brought the target into his sights, and fired. His attention was focused on one thing, on accuracy. The loader, after each shot, rammed the next shell. Quickly, with practiced movements, without distracting either the commander or the gunner. 3 people, 3 tasks, 3 streams of attention, in parallel, without interfering with each other. In practice, this gave a difference that could be measured in seconds. While the commander of a Sommois S-35 was looking for a target in his sights again after a shot, the commander of the III already saw the next one and was already giving a command to the gunner. This is not just a convenience. In tank combat, seconds decide everything. There is another detail that is rarely talked about. The commander of the III, not busy with the gun, could fully work with the radio station. Remember that 1934 requirement, a radio in every vehicle? That is when it worked to its full strength. The commander saw the battlefield, assessed the situation, and immediately transmitted the information, without pauses, without switching between tasks. A platoon of threes on the battlefield was not just a group of vehicles. It was an interconnected system where each element saw and heard the rest. When, after the completion of active combat operations, designers from different countries sat down to design a new generation of tanks, A three-man turret with a clear division of duties became the standard almost everywhere. The British, the Americans, Soviet engineers, starting with the T-54 tank, all came to the same layout. The III did not live to see this moment as a frontline combat vehicle, but it was the one that proved the scheme worked. However, the right turret is only half the story. Because the turret stands on the hull, and the hull stands on the chassis, and the way the III moved on the ground was no less important an invention than how it looked and fired. There are things you only start to appreciate when they aren't there. A good road, a quiet engine, a flat floor under your feet. The crew of a tank of the late 1930s was deprived of all this by definition, but the degree of deprivation depended heavily on which vehicle you were sitting in. Imagine this picture. A tank is going across a field, over uneven ground with bumps, holes, and washouts. Inside are 5 men. The driver maintains the course, shifts gears, reacts to obstacles. The gunner holds the target in his sights. The commander looks into his cupola and gives commands. Now add severe shaking. Not a light sway, but a real, sharp one, when your head hits the metal and your hands slip off the handles. What happens to the sight? It jumps. What happens to the commander? He loses the picture. What happens to the radio communication? The sentence breaks off in the middle because your teeth clenched from the impact. This is exactly what a fight on vehicles with primitive suspension looked like. Not a catastrophe, just a constant, exhausting chaos of minor failures. The torsion bar suspension solved this problem. Not completely, but it solved it better than anything that existed at that time. We have already talked about how the torsion bar is arranged. It works on twisting, takes the impact from the road wheel, and elastically returns to its original position. But there is one nuance that is worth mentioning separately. On the III, each of the road wheels on each side was suspended on its own torsion bar, independently of the neighbors. This is fundamentally important. Let's take a leaf spring for comparison. It connects several wheels simultaneously. When one wheel hits a hole, the spring bends, and this movement is transmitted to the neighboring road wheels as well. The hull of the vehicle receives not one point impact, but a whole wave. The vehicle rocks. Torsion bars work differently. One wheel in a hole, its torsion bar twists, takes the impact, and returns. The neighboring wheel barely feels it. The hull does not rock in a wave. It glides over obstacles as if the road wheels beneath it live each their own life, and the upper part of the vehicle does not know about it. This is not abstract mechanics. These are concrete seconds of aiming. When the vehicle goes smoothly enough, the gunner can hold the target in his sights not only at a stop, but also on the move. Not perfectly, not like in a shooting gallery, but enough to open fire without losing the pace of the attack. This is called firing on the move, and in the late 1930s, it was the privilege of very few vehicles. There is another consequence that is rarely thought of first. A smooth ride reduced crew fatigue. This sounds almost banal, but it is actually strategically important. A tank raid could last many hours in a row. A crew that spent these hours in constant shaking arrived at the place of battle already exhausted. Reactions are slowed down, attention is scattered, hands are tired of fighting the controls. The crew of the III arrived in better condition, not rested but less worn out, and this accumulated over distance. The torsion bar suspension also had a practical advantage from the point of view of repair. The bars were located inside the hull across the vehicle, protected from external damage. Reaching them was not easy, but if one bar was damaged, the rest continued to work. The vehicle did not lose mobility completely, it just ran slightly worse in one section. In field conditions, when the repair crew is working under the open sky and without stationary equipment, the ability to replace one element without dismantling the entire structure was worth a lot. By 1940, when the production IIIs of Series E and F began to enter the tank divisions, the combination of a three-man turret and torsion bar suspension created a machine that knew how to do what most of its opponents did not. It could move, see, and shoot at the same time. All three actions, in parallel, without forced stops, without pauses for reorganization. Only one thing remained: to test all this in real conditions. And the conditions did not keep them waiting. Autumn 1939, Poland. Threes march in columns along roads that were peaceful until recently. Dust, the hum of engines, the clatter of tracks. For the first time, the machine that had been worked on for 5 years met reality, and reality did not disappoint it. The 37mm gun, designated KWK-36, This is an abbreviation of the German Kampfwagenkanone, meaning tank gun, 36 being the year of adoption, was a weapon tailored for one task: speed. Not the destructive power of a heavy shell, but a high rate of fire and accuracy at distances where tank clashes usually occurred in the late 1930s. The Polish campaign showed the gun could cope. The enemy's armor was mostly light. Polish tanks of that time were vehicles with bulletproof armor between 8 and 13 millimeters thick. The 37mm shell of the III penetrated such protection confidently, at distances up to 500 meters with virtually no difficulty. But the system as a whole turned out to be far more important than the hardware. A platoon of threes moved cohesively. Commanders heard each other over the radio, reacting to changes in the situation without stops and reorganizations. If one crew noticed a threat, the information went on the air immediately. Neighboring vehicles changed course without waiting for flags and light signals. For an enemy whose units coordinated significantly slower, this looked almost inexplicable. The German machines seemed to know in advance where to move. They did not know in advance, they just talked to each other faster. Spring 1940. France and the Benelux countries, Belgium, the Netherlands, and Luxembourg. Here the enemy was more serious. French vehicles, the Somoa S-35 itself and the heavy Char B-1, had armor from 40 to 60 millimeters thick. The 37mm gun of the III worked at its limit against such targets. At short distances, with lucky impact angles, it coped. At medium distances from the front, already with difficulty. This was the first quiet signal. It was not ignored then, but they did not see a big problem in it either, because the campaign ended quickly and the decisive role in it was played not by individual tank duels, but by the pace and depth of the maneuver. The III participated in this pace to the full. By the summer of 1940, the III occupied the place of the main combat vehicle in the tank divisions. The main burden in the anti-tank struggle fell on it. The Panzer IV, with its short 75mm gun, a weapon with a short barrel originally intended for firing heavy, high-explosive fragmentation shells at fortifications and infantry, worked alongside, but in a different role. The division of tasks, conceived back in 1934, worked exactly as planned. And here it is important to stop for a second. In 1940, the III was at the peak of its form. The design was honed, the crews were trained, the tactics were worked out. The machine did exactly what it was created for, and did it well. But within this success already lay a contradiction that no one yet saw in full stature. The 37mm gun was good only as long as the enemy played by the familiar rules: light armor, small distances, vehicles that were designed around the same years and with the same limitations. But the rules were already changing, just no one knew about it yet. Thousands of kilometers to the east, on test grounds and in design bureaus, there already existed machines against which 37mm meant nothing, at all. And meeting them was no longer a question of possibility, only of time. In the summer of 1941, German tankers faced something they had not been prepared for. Not bad weather, not difficult roads, but machines that did not react to hits the way they were supposed to. The crews of the threes saw how the shell went exactly to the target, heard the sound of the impact, and watched as the enemy tank continued to move. This was the T-34, the Soviet medium tank, developed in the late 1930s, carried armor of a fundamentally different design. Not just thick, sloped. The frontal sheet of the hull was located at an angle of 45 degrees to the vertical. This solution seems simple at first glance, but its consequences were very serious. When a shell flies into a vertical armor plate, it meets it at a right angle and spends all its energy on penetration. When the same shell flies into a sloped plate, two effects occur at once. First, the shell needs to penetrate not just the thickness of the plate, but a greater distance diagonally. The 45mm sloped plate of the T-34 worked roughly like a 70mm vertical one. The second effect is that the shell tends to ricochet, to slide off the inclined surface without transferring all its destructive energy to the armor. The 37mm gun of the III at medium and long distances could do virtually nothing against such protection. Shells ricocheted or got stuck in the armor without penetrating it. But the T-34 was not even the heaviest discovery of that summer. There was also the KV-1, a Soviet heavy tank with vertical armor from 70 to 75 millimeters thick on the front of the hull. Vertical, meaning without the advantage of slope, but simply very thick, 75 millimeters of vertical armor. To understand what this is, let's take a simple comparison. A standard brick is about 65 millimeters thick. The KV-1 was protected by a thickness slightly larger than a single brick of solid steel. The 37 millimeter shell of the III against such protection was completely powerless, even point blank. The realization of this fact for German tankers in the summer of 1941 was sharp. A vehicle that a year ago confidently coped with its task suddenly stopped being a tool for anti-tank struggle, exactly for the task for which it had been created from the very beginning. The 37mm gun turned out to be useless, not against everything met on the field, it still hit light vehicles, but against what was now setting the tone, against the T-34 and KV-1, it did not work. German engineers knew about these Soviet vehicles. Intelligence data existed, but it was only possible to fully assess what exactly a meeting with them meant in practice when it happened in reality. The reaction was immediate. Already in 1941, some of the threes began to receive a new weapon, a 50mm gun with a barrel length of 42 calibers. This means that the barrel was 42 times longer than its diameter, about 2 meters 10 centimeters. The designation of this gun was KWK-38, that is, Tank Gun Model of 1938. It was significantly more powerful than its predecessor, confidently worked against light and medium armor, and gave a chance against the T-34 at short distances with a lucky impact angle. A chance, but not a guarantee. The engineers understood this. Therefore, work on the next weapon began almost simultaneously. While the crews were mastering the new guns, the design bureaus were already calculating how much more could be squeezed out of the hull of the III, how much armor it could still withstand, what gun would still fit in the turret, where the limit lay, beyond which modernization ceased to make sense. The answers to these questions turned out to be not as encouraging as they would have liked, but before this limit was reached, the III got another chance, and used it in its own way. When a machine stops coping with its task, engineers have two paths. The first is to create a new machine from scratch. This is correct, but slow. A new project requires months of design, testing, and production debugging, and the front will not wait. The second path is to take what is there and squeeze the maximum out of it, fast, right now. In 1941, German engineers chose the second path, and for several years they methodically, step by step, moved along it, up to the point where moving further became physically impossible. The first step was the replacement of the weapon. The short-barreled 50mm gun, KWK-38, Tank Gun Model 1938, with a barrel length of 42 calibers, gave the III a temporary respite. It worked more confidently against medium armor, and at short distances gave a chance against the T-34. But exactly a chance, not confident work. The engineers understood this. Therefore, almost immediately, work began on the next weapon. It became the long 50mm gun, KWK-39, Tank Gun Model 1939, with a barrel length of 60 calibers. 60 calibers means that the barrel was 60 times longer than its diameter, about 3 meters. For comparison, the previous version had a barrel about 2 meters 10 centimeters long, a difference of almost a meter. Why is barrel length so important? The longer the barrel, the longer the powder gases push the shell inside it after the shot. The shell manages to pick up high speed before leaving the muzzle. And speed is energy, and energy is penetration capability. The long 50mm gun accelerated a standard armor-piercing shell to about 835 meters per second. This is almost 3 times faster than an arrow shot from a bow, and about 2.5 times faster than the speed of sound in air. At a distance of up to 500 meters, such a shell penetrated armor about 60 millimeters thick at a right angle of impact. Against the T-34, this gave a real result at short distances. Against the KV-1 in front, still with difficulty, but in the side and rear, the machine already worked confidently. In parallel with the rearmament, work was going on protection. The initial armor of production IIIs was 30 millimeters on the front of the hull. This was enough against light guns, but against what began to be met on the eastern direction from the summer of 1941, it was not enough. The first solution was to increase the thickness during production. New vehicles received frontal armor of 50 millimeters. Not welded additional sheets, but a single plate of this thickness from the factory. But this also turned out to be not enough. Then the next solution appeared, applique armor. Additional armor plates, 20 millimeters thick, were bolted to the front of the hull and turret. The total protection in the frontal projection reached 70 millimeters. And this is where that very ceiling manifested itself. 70 millimeters of armor, plus a long 50 millimeter gun, plus a reinforced transmission, all of this weighed. The mass of the III began to grow. The initial 21 to 23 tons of early series, by the end of production grew to about 23 tons in the basic late version, and with applique armor and additional equipment, the machine approached 25 tons. The torsion bar suspension, designed for a certain load, began to work at the limit. The 300 horsepower engine, which on early versions provided good mobility, now dragged a significantly heavier vehicle. The maximum speed fell, the range was reduced. The vehicle became heavier, slower, and still barely coped with the targets against which it was supposed to work confidently. This is the ceiling of modernization, the moment when further improvement of one characteristic inevitably worsens another. More armor, less speed. More powerful gun, heavier turret. Greater load on the suspension. Stronger engine, more complex transmission. Higher probability of breakdown. The design of the III found this ceiling. The turret ring, the circular rail on which the turret rotates on the hull, had a diameter of about 1 meter 52 centimeters. This was a hard limit. A gun of a larger caliber or significantly greater length simply did not fit in such a turret without a complete redesign. And redesigning the turret meant virtually a new vehicle. The engineers reached the edge and stopped. At this moment it became clear. Further development of the III as the main medium tank with an anti-tank function lost its meaning. The machine did everything it could. It honestly went the way from 37 to 50 millimeters in caliber, from 30 to 70 millimeters of armor, from 21 to 25 tons of mass, and hit a wall. What happens when a good machine reaches its limit is a separate story. Sometimes it is simply removed from production and forgotten. But with the III, it turned out differently. There is a moment in the life of any tool when it stops being the best for its task. It does not break. It does not disappear. Just something appears next to it that copes better. And then you need to honestly answer the question, what to do next? For the III, this moment came in 1942. The Panzer IV, the machine that went alongside from the very beginning in a neighboring role, had changed beyond recognition by this time. The short-barreled gun, intended for infantry support, gave way to a long 75mm gun KWK-40, a tank gun of 75mm caliber with a barrel length of 43 and then 48 calibers. This weapon penetrated the armor of the T-34 at distances inaccessible to the long 50mm gun of the III. Confidently, with a margin, without the need to look for a lucky angle. The difference was obvious to everyone who worked with both machines. 37mm in 1939 was sufficient. 50mm in 1941 gave a chance. 75mm in 1942 gave confidence. And this confidence now lived in the Panzer IV, not in the III. The decision to stop serial production of the basic version of the Panzer III was made in 1943. The last vehicles came off the assembly line in the same year. In total, over the years of production, about 5,600 IIIs of all modifications were produced. This is a lot, but it is not a matter of number. It is a matter of what happened during these years and what remained after. Let's stop and look at the whole picture at once. In 1939, the III formed the backbone of the tank divisions. It was on it that the breakthrough tactics relied. It was it that bore the main load in the anti-tank struggle. The Panzer IV was next, but in a subordinate role. By 1942, the picture turned upside down. The Panzer IV with a long gun became the main tank. The III was gradually receding into the background. But the background is not the end. It is a change of role. In tank units, the IIIs began to be used differently. As a commander's vehicle, when a senior officer of a unit needed a protected, mobile command post with good visibility and reliable radio communication, the III was very well suited for this. Its cupola with all-round observation and standard radio station, those very qualities that made it a strong combat tank, now worked in a new function. As an artillery observation post, an advanced artillery observer needed an armored vehicle capable of moving to the front line and correcting fire by radio. The III again turned out to be in place. protection sufficient, visibility good, communication reliable. In North Africa, where the Corps under the command of General Rommel operated in 1941 and 1942, threes fought in special conditions. The desert is a flat, open area with long distances of observation and combat. Here, the long 50mm gun worked somewhat more effectively than on the Soviet direction, simply because anti-tank distances in the desert often turned out to be medium rather than long. British tanks of that period, cruiser vehicles with bulletproof or light armor, were more suitable targets for 50mm than the T-34. But here too, the time of the III as the main strike force was limited. Near Kursk in the summer of 1943, in one of the largest tank battles in history, the threes already played auxiliary roles. The main burden was borne by Panzer IVs, assault guns, and new heavy vehicles. The III was present on the field, but not as a central figure. This is not a failure. This is the natural course of things. A machine created for the conditions of the late 1930s held on the front line for 5 years, adapted, changed, received new weapons and additional armor. It did everything in its power and did it honestly. And when the time came to yield place to newer machines, it did. But the history of the III did not end there, because while the machine itself was leaving the main roles, its chassis, hull, suspension, chassis continued to live, and to live very actively. So actively that in the end, it was this chassis and not the tank itself that became the most numerous German armored vehicle of all time. For this, only one thing was needed: to remove the turret. Sometimes the best solution is to remove something, not to add it. In engineering, this is called simplification. In life, common sense. German designers applied this principle to the chassis of the III and got a machine that in the end turned out to be more important than the tank itself. The idea of an assault gun arose before the III managed to become obsolete as a tank. Back in the late 1930s, there was a demand in the Army for an armored vehicle capable of accompanying infantry in the offensive and suppressing fortified points with direct fire. Not a tank in the classical sense, but something in between a self-propelled gun and a support assault vehicle. The chassis of the III suited this role almost perfectly. Designers took the hull, removed the turret, and installed a fixed armored superstructure in its place, a closed armored compartment with a gun that could be aimed in a small horizontal sector, but did not rotate in a circle like a turret. The vehicle received the official designation Sturmgeschütz III. In German, this means assault gun of the third model, abbreviated as StuG III. What did this solution give in practice? The first and most obvious is height. The turret is the highest point of the tank. Removing it and replacing it with a low superstructure, the designers got a machine about 2 meters 20 centimeters high. For comparison, the III itself with a turret had a height of about 2 meters 50 centimeters. A difference of 30 centimeters seems small at first glance, but on the field it meant a great deal. The lower the vehicle, the less it is seen. The easier it is to hide it behind an embankment, in a fold of terrain, behind a building or trees. The smaller the area into which an enemy shell can hit. A low silhouette is not just aesthetics, it is survivability. The second advantage is simplicity of production. A tank turret is a complex and expensive element. It must rotate, which means a turret ring with precise tolerances is needed. It carries the gun with mechanisms for horizontal and vertical guidance, sights, shell racks, workplaces for several people. All of this requires precise manufacturing, high-quality materials, and significant assembly time. A fixed superstructure is simpler. It does not rotate. Tolerances are less critical. There are fewer parts. The production cycle is shorter. Under conditions where industry was working at maximum load, this had direct practical significance. In the same time and with the same resources, more machines could be produced. The third is the gun. Early versions of the Sturmgeschütz III carried a short 75mm gun, intended for firing high-explosive fragmentation shells at fortifications. But after the events of 1941, the vehicle was rearmed. The new weapon, the long 75mm gun StuG IV, where StuG stands for Sturmkanone, meaning assault gun, with a barrel length of 43 and then 48 calibers, turned the Sturmgeschütz III into a fully fledged tank destroyer. This gun was close in its characteristics to the weapon of the Panzer IV of late series. That is, a machine created as an infantry support weapon received anti-tank capabilities comparable to the main tank of the same period. At the same time, it remained lower, cheaper to produce, and easier to maintain. The result speaks for itself. Over the years of production, more than 10,000 Sturmgeschütz III units of all modifications were produced. 10,000. This is more than any other separate type of armored vehicle over the same period. More than the III itself. More than the Panzer IV. The most numerous armored unit. Think about it for a second. A machine created by removing the turret from another machine became in the end more numerous than the machine with which it all started. The chassis outlived the original and surpassed it in scale of application. There is something symbolic in this. The design that Daimler-Benz engineers honed in the mid-1930s, torsion bar suspension, hull, layout, chassis, turned out to be so successful that it continued to work even when the original intent had already exhausted itself. The chassis was alive, and it had not yet said its last word. Because in addition to the assault gun, they made something else out of it. Several things, actually. And each of them speaks of how versatile the original design turned out to be. There are people who, after their main career, find a second calling. They leave one position and discover that in another they are needed no less, and sometimes more. With the III, roughly the same thing happened. When in 1942 it became clear that in the role of the main tank, the machine would be replaced by the Panzer IV, the commanders of the units did not send the IIIs to the rear. They began to think, what is this machine best suited for right now with what is in it? There turned out to be several answers. The first, and most natural, a commander's vehicle. Let's return to what the III started with. It was designed with the commander in mind. Good all-round visibility from the cupola. Standard radio station. A three-man turret where the commander is not distracted by the sight and loading, but only observes and controls. All of this made the III an almost ideal command post on wheels. A senior officer of a tank unit needs a vehicle from which he sees the battlefield, hears all his crews, and can quickly move to where the situation requires his presence. A heavy tank for this role is redundant and clumsy. A light armored car is too vulnerable. The III fell exactly into the right gap. Commander versions received additional radio stations, sometimes removing part of the ammunition load to free up space for maps and communication equipment. The machine turned into a mobile control hub, capable of working directly at the front line. The second option, an artillery observation post. This is a less obvious but extremely important role. The artillery of that time fired from closed positions, that is, from places from which the target was not visible. In order for the shells to land accurately, someone had to see the bursts and correct the fire by radio. This someone, the forward observer, had to be close to the front line, have good visibility, and reliable communication, and at the same time remain alive long enough to manage to correct the fire. An armored vehicle with good visibility and a radio station was better suited for this task than any other option. The III in this role was equipped with special rangefinders and additional means of communication. The gun remained in place in case the situation changed. The third area, North Africa. In 1941 and 1942, the German Africa Corps under the command of General Rommel operated in conditions fundamentally different from the Soviet direction. The desert is an open space with good visibility and, as a rule, long distances between opponents. Under such conditions, the III, with a long 50mm gun, worked noticeably more effectively than where it was necessary to close in point blank with T-34s and KV-1s. British cruiser tanks, fast machines with relatively light armor, designed for maneuvering actions, turned out to be more suitable targets. Armor of 20 to 40 millimeters against a 50mm shell at medium distances, this is another story. In North Africa, the III fought until 1942 to 1943, and until the end remained a combat-capable machine in the specific conditions of the theater. The fourth direction, engineering and special versions. The chassis of the III turned out to be a convenient platform for several non-standard applications. Recovery vehicles capable of towing damaged equipment or artillery pieces, armored ammunition carriers for supplying forward positions, special versions with equipment for overcoming water obstacles, Early variants provided for underwater driving at shallow depths. Each of these versions solved a specific task for which other machines were either not suitable or too expensive to produce. And finally, Kursk, summer of 1943. By this time, the III and the role of a line tank had practically disappeared from frontline units, but it was present on the field in other capacities. Commanders' vehicles worked in unit headquarters. Artillery observers moved behind the advancing formations. Special versions performed support tasks. The machine that in 1939 went first in the attack now supported those who went first instead of it. This is not humiliation. This is an honest assessment of capabilities and a calm readiness to do what works best here and now. The III succeeded in many things, and what it knew how to do best, to see, hear, connect people into a single whole, turned out to be needed until the very end. But behind all these roles, behind all this history of adaptations and changes of profession, stands a question that is more important than any specific detail. What exactly did the III leave behind? Not in museums and not in archives. In the very idea of what a tank should be. When a bridge has done its work, it is usually forgotten. They look at what is on the other bank, at what became possible thanks to the crossing, and the bridge itself remains behind, and few look back. This is exactly what happened with the III. Post-war tank building followed the path that the III outlined back in the late 1930s. A three-man turret with a clear division of duties became the standard everywhere. The Soviet T-54 tank, adopted for service in 1946, carried a three-man turret: commander, gunner, loader. The British Centurion, the American M48 Patton, the French AMX-30, all of them followed the same logic of distribution of people inside the turret that German designers had worked out on the III even before the beginning of the 1940s. No one copied the III intentionally. Everyone just came to the same conclusion through practice. And the III came to it earlier. But it is not only a matter of the turret. The III became the first production machine where several principles merged simultaneously and began to work as a single system. Division of duties in the crew, torsion bar suspension for stability when firing on the move, standard radio station in each vehicle for constant communication, commander's position with all-round visibility free from working with the gun. Each of these elements individually was met earlier in different machines, but it was in the III that they first merged into a coherent concept, which then became a model. This is the technological bridge. Not a separate invention, but a combination of several correct decisions in one whole at the right moment. Now let's look at another legacy: tactical. On the III, a whole layer of what would later enter all textbooks on the theory of maneuvering actions of armored forces was worked out. How the crew interacts inside the vehicle under rapidly changing conditions. How a platoon of vehicles is coordinated by radio without stops. How a company operates in a dispersed order, maintaining at the same time unified control. How to combine movement and fire so that the enemy does not have time to react. This all sounds like abstract theory, but behind each of these points stand concrete hours on test grounds, concrete maneuvers in Poland and France, concrete conclusions that officers wrote down in reports and analyses after each operation. The III was the training school desk on which these conclusions were made. And another point that is worth stating directly: the III is obsolete. This is a fact. By 1943, it was inferior to its main opponents in all key indicators: gun caliber, armor thickness, crew protection. This is also a fact. But obsolescence is not a failure. It is the normal finale of any machine created under specific conditions of a specific time. Conditions changed. The machine remained itself. It could not endlessly keep up with new requirements, and honestly reached its limit without wasting itself in vain. In this sense, the III lived a proper life. It appeared when it was needed, did its job as well as it knew how, changed as long as it made sense, and yielded its place when the time came. And its chassis continued to work in Sturmgeschütz III, assault guns that were produced until the last months and became the most numerous armored vehicles of all time. The design turned out to be so well thought out that it outlived itself. There is a special category of machines in technical history. Not the most famous, not the most formidable, not those whose names everyone knows, but those that made everything else possible. Those on which others learned, worked out, understood, and went further, taking someone else's experience as their own. Panzer III, the III, is from this category. A modest machine with an inconspicuous silhouette, 5 people inside, and a radio station in each copy. A machine that was conceived as a platoon commander's tank, and which in the end became the blueprint for a whole generation of armored vehicles. Bridges are not always remembered, but it is over them that they cross to the other bank. And next time you see a photograph or a drawing of any post-war medium tank with a 3-man turret and torsion bar suspension, know, somewhere at the base of this design is the imperceptible, quiet, honest contribution of the 3.